Hi friends, welcome back to my YouTube channel. So today I'm going to discuss about spectrum multiple access, SSMA and CDMA, and this is from module 6 from Advanced Communication System EC404 from KTU syllabus for BTECH Electronics and Communication Engineering students. So you can refer these notes for your exam, and also we have already discussed about FDMA, TDMA in previous videos. You can also refer that. So these all are related to multiple access techniques. So SSMA, CDMA, FDMA, TDMA, all are multiple access techniques. So the last one is CDMA in SSMA techniques. So first we are going to discuss about spectrum multiple access techniques. So what is spectrum multiple access? So SSMA uses signals which have a transmission bandwidth that is several orders of magnitude greater than the minimum required RF bandwidth. So SSMA means it's a frequency or the transmission bandwidth that is several order of magnitude greater than the minimum required RF bandwidth. So a pseudo noise sequence PN sequence converts a narrowband signal to a wideband noise like signal before transmission. So what they are doing, a PN sequence convert a narrowband signal to a wideband noise like signal before transmission. So while transmitting the signal to sender to receiver, that PN sequence convert the pseudo noise sequence converts a narrowband signal to a wideband signal before transmission. So SSMA also provides immunity to multipath interference and robust multiple access capabilities. And SSMA is not very bandwidth efficient when used by a single user. So when it is used by a single user, we cannot say it is efficient in SMA. Multiple access is not efficient when it is used by a single user. However, since many users can share the same spectrum bandwidth without interfering with one another, spectrum system become bandwidth efficient in a multiple user environment. The thing is that it is non-efficient when it is used by one user, but it is efficient when it is used by multiple users in an environment. So there are two main types of spectrum multiple access techniques: frequency hopped multiple access (FH) and direct sequence multiple access (DS). And direct sequence multiple access is also called code division multiple access, that means CDMA. So there are two types of techniques, FH and DS. So the FH means frequency hopped multiple access and DS means direct sequence multiple access, and CDMA is one of these direct sequence multiple access techniques. So first we are going to discuss about frequency hopped multiple access techniques, I mean FHMA. So frequency hopped multiple access techniques in digital multiple access system in which the carrier frequency of the individual users are varied in the pseudo random fashion within the wideband channel. So the frequency is variable in nature. So in frequency hopped multiple access techniques, those carrier frequencies of the individual users are varied into a pseudo random fashion within the wideband channel. And the digital data is broken into uniform sized bursts which are transmitted on different carrier frequency. So the data are broken down to uniform sized bursts, and also it is transmitted in different frequency also. And the instantaneous bandwidth of any one transmission burst is much smaller than the total spread bandwidth. And the pseudo-random change of the carrier frequency of the user randomize the occupancy of a specific channel at any given time, thereby allowing for multiple access over a wide range frequency. So in the FH receiver, a locally generated PN code is used to synchronize the receiver's instantaneous frequency with that of the transmitter. So in frequency hopping multiple access techniques, the receiver, a locally generated PN code is used to synchronize the receiver instantaneous frequency with the transmitter. So we are using a locally generated PN code to synchronize the receiver instantaneous frequency with transmitter frequency. So at any given point of time, a frequency hopped signal only occupies a single relatively narrow channel, since narrowband FM frequency multiple access or FSK is used. The difference between FHMA and traditional FDMA system is that In the frequency hop signal changes channel at rapid intervals. The frequency will be changed rapid in interval. And if the rate of change of the carrier frequency is greater than the symbol rate, then the system is referred to as a fast frequency hopping system. So the change of frequency is greater than the symbol rate, then it is called as fast frequency hopping system. If the channel changes at a less rate or rate less than or equal to symbol rate, it is called slow frequency hopping. So if the carrier frequency greater than the symbol rate or the rate of change of carrier frequency is greater than the symbol rate, then it is called fast frequency hopping system. If the rate is less than or equal to symbol rate, then it is called slow frequency hopping. A fast frequency hopper may thus be thought of as an FDMA system which employs frequency diversity. So a fast frequency hopper is known as FDMA system. And FHMA system often employ energy efficient constant envelope modulation. Inexpensive receivers may be built to provide non-coherent detection of FHMA. And this implies the linearity is not an issue, and the power of multiple users at the receiver does not degrade in FHMA performance. And the frequency hopped system provides a low level security, especially when a large number of channels are used, since an unintended or intercepting receiver that does not know the pseudo random sequence of frequency slot must retune rapidly to search for the signal it wishes to intercept. So in addition to FH signal is somewhat immune to fading, since error control coding and interleaving can be used to protect the frequency hop signal against deep fades which may occasionally occur during hopping sequence. Error control coding and interleaving can also be combined to guard against erasure, which can occur when two or more users transmit on the same channel at the same time. So that is all about FHMA. So this is from frequency hop multiple access techniques. So next one is direct sequence multiple access technique from SSMA techniques. So one of the example for DS is code division multiple access. So in code division multiple access CDMA system, the narrowband signal message signal is multiplied by a very large bandwidth signal called spreading signal. So here the narrowband signal is multiplied by a large bandwidth signal called spreading signal. The spreading signal is a pseudo noise code sequence, and that has a chip rate which is in order to magnitude greater than the data rate of the message. So the spreading signal is a pseudo noise code sequence, and that has a chip rate which is order of magnitude greater than the data rate of the message. All users in a CDMA system, you can see in the figure number is wrong, you can see the figure in the next page. This is the figure for CDMA system. So there are channel 1 to n channels are present in the time and frequency section. So in figure uses the same carrier frequency and may transmit simultaneously. So here it is using same carrier frequency and transmit at the same time. Simultaneously it transmit. Each user has its own pseudo random code word which is approximately orthogonal to all other code words. So the receiver performs a time correlation operation to detect only a specific desired code word. All other code word appears as a noise due to decorrelation. So here what it is doing, receiver perform time correlation operation to detect a specific desired code word, and all other code words are appears to be a noise due to decorrelation. For detection of the message signal, the receiver needs to know the code word used by the transmitter, and each user operates independently with no knowledge of the other users. So in CDMA, the power of multiple users at receiver determines the noise floor after decorrelation. If the power of each user within the cell is not controlled such that they do not appear equal at the base station receiver, then the near-far problem occurs. The near-far problem occurs when many mobile users share the same channel. In general, the strongest received mobile signal will capture the demodulator as a base station. In CDMA, stronger received signal level raise the noise door at the base station demodulator for the weaker signal, thereby decreasing the probability that weaker signal will be received. So to combat the near-far problem, power control is used in CDMA implementation. So the power control is provided by each base station in a cellular system and assures that each mobile within the base station coverage area provides the same signal level to the base station receiver. This resolves the problem of nearby subscriber overpowering the base station receiver by drowning out of the signal of far away subscriber. And power control is implemented at the base station by rapidly sampling the radio signal strength indicator RSSI level of each mobile and then sending a power change command over the forward radio link. Despite the use of power control within each cells, out-of-cell mobiles provide interference which is not under the control of the receiving base station. So some features of CDMA includes many users of CDMA systems share the same frequency, either TDD or FDD may be used. And noise, unlike TDMA or FDMA, CDMA has a soft capacity limit, increasing the number of users in a CDMA system, raise the noise floor in linear manner. Thus, there is no absolute limit on the number of users in CDMA. Rather, the system performance gradually degrades for all the users as the number of users increased and improves as the number of users decreased. So what we can say is like there is no absolute limit on the number of users in CDMA. So in other system like TDMA, FDMA, there is a capacity limit. So in CDMA there is no capacity limit, there is no absolute limit of the number of customers used in CDMA. So and the system performance gradually degrades for all users as the number of users is increased and improves as the number of users is decreased. So that is the condition. So multipath fading may be substantially reduced because of the signal is spread over a large spectrum, and if the spectrum bandwidth is greater than the coherent bandwidth of the channel, the inherent frequency diversity will mitigate the effect of small scale fading. So multipath fading is reduced here because the signal is spread over the large spectrum, and also if the spectrum bandwidth is greater than the coherence bandwidth of the channel, then it can mitigate the effect of small scale fading. And channel data rates are very high in CDMA system, so consequently the symbol or chip duration is very short and usually much less than the channel delay spread. Since PN sequence have low autocorrelation, multipath which is delayed by more than a chip will appear as noise. A rake receiver can be used to improve reception by collecting the delayed version of the required signal. Since CDMA uses co-channel cells, it can use a macroscopic spatial diversity to provide soft handoff. And soft handoff is performed by the MSC, which can simultaneously monitor particular user from 2 or more base stations. The MSC may choose the best version of signal at any time without switching frequency. And next feature of CDMA, self-jamming is a problem in CDMA system. Self-jamming arises from the fact that the spreading sequences of different users are not exactly orthogonal. Hence, despreading of a particular PN code or non-zero contribution to the receiver decision statistics for a desired user arise from the transmission of one user to the system. The near-far problem occurs at the CDMA receiver if an undesired user has a high detected power as compared to the desired user. So near-far problem is also a feature of CDMA. So what we can say is like CDMA is used either by TDD or FDD, and CDMA has no absolute limit of the number of users in CDMA. So the performance gradually degrades if the number of users increase, or performance will be improved if the number of users is decreased. And multipath fading is reduced in CDMA, and channel data rates are very high in CDMA. and it can be used a macroscopic spatial diversity to provide soft handoff, and self-jamming is a problem in CDMA system, and also near-far problem occurs in CDMA. So these are the features of CDMA system. That's all about today's video, and you can refer this video. So this is all about SSMA system, SSMA spread spectrum multiple access techniques. We have discussed FHMA, frequency hopping multiple access techniques, and direct sequence multiple access techniques. So we have discussed SSMA and CDMA. CDMA is also called direct sequence multiple access. So also when you are studying, also refer the previous videos about FDMA and TDMA. So now we have completed the CDMA part, and in next section we will continue on the SSMA, the next part of SSMA classifications. So we will see you in the next video. If you like this video, please subscribe my channel, like, share and comment. Thank you. See you in the next video.